All right. Now that we've talked about what a vector map looks like, I like to put fun things up here, but this one seemed really relevant with us just starting vectors. And I do like to try to relate what we do here to any other discipline where you might see those same concepts come up. In your notes, where did it go? There it is. We had just started talking about component form and wedge notation. Wedge notation just means that I know when I'm looking at it, they're telling me, hey, this is a vector. Not it's an ordered pair, not it's an interval. Have you guys noticed at this point that math tends to recycle notation? Like we're going to use parentheses for an ordered pair. Oh, but we're also going to use parentheses for an interval if it's an open interval where I don't include it. Oh, we're going to use this notation here. Math recycles a lot of notation. So to try to avoid confusion, they're using this wedge notation, which when you go to type it into the computer, like for your homework on Canvas, it's the greater than, less than signs. That's what you're going to be putting around these ordered pairs. When we write it in wedge notation, when we write it in component form, it's taking my vector, wherever it happens to be on the graph, and it is relocating it. Because remember, with vectors, location doesn't matter. What are the two things that matter with vectors? What are the only two things that matter with vectors? Direction and magnitude. Position is irrelevant, so I can move it around on my graph, and it's still the same vector. Writing it in component form with wedge notation takes my initial point, wherever it used to be, and it translates it to the origin. And then the wedge notation tells me the new location of the terminal point. That makes it much easier for me to be able to determine what the magnitude is and what the direction is by relocating it. So I want to practice doing that with these. We want the change in x, so x2 minus x1, to get the x part of our wedge notation, our component form, y2 minus y1. So let's find component form for number 1. For my vector AB, I want to subtract my x's. What's x2? Yep, 6 minus x1, which is negative 2. Well, what happens when I subtract a negative? Yeah, that turns into 6 plus 2, which is what? So I have 8. And then I still need the y part. So I do y2 minus y1. So 1 minus what? 1 minus negative 7, which is again 8, because I do 1 plus 7, so 8. So there's component form for my vector AB. Let's do the exact same thing on number 2. I want to find component form for this vector. So use my wedge notation. How do I find the change in x? Subtract. Tell me what two numbers to subtract. Close. Negative 9 minus 0, because it's always the second one minus the first one, because I want to find out how much it changed. In this case, did it change? I've got negative 9. And then what do I do for the y part? Negative 3 minus 8, which gives me what? Negative 11. No, that's okay. You guys okay with that so far? Yes? No? Okay. Once I have it in this form, I can tell what quadrant the terminal point would be in. What quadrant would this terminal point be in? Where is the point 8, 8 on a map or on a graph? First quadrant, right? It's going to be up here. And so this would be in quad 1. What quadrant is number 2 in? Quad 3. We're going to use this component form once we've translated it into standard position. Again, that's what component form does for me. We're going to use that to determine both the magnitude, the strength of this, which we represent graphically how? How do I know if it's a bigger strength or a bigger force or a smaller force? Yeah, the length of the line segment. So what we're going to do to find the magnitude, and there's a slight typo on your page, this should actually be a double set of lines around our vector. A single set of lines is absolute value. That double set means magnitude. To find our magnitude, we're going to square the two components. We're going to add them together, and then we're going to square root them. This is exactly the same as the distance formula. Like if I wanted to know the length of the hypotenuse of a triangle, we would do a squared plus b squared equals c squared. That's what this is right here. So that is to find our magnitude. Distance or length of the line segment. To find the direction, we're going to use inverse tangent. Why are we using tangent instead of sine or cosine? Yes, x and y. If you remember from our unit circle, tangent is y over x. And we have a component where we have y and x. So we're going to use inverse tangent to determine the degree of rotation here. So what is its angle? There's only one issue with tangent. Inverse tangent can only give me angles in which quadrants? 1 and 4. What about if from my component form, I know I'm not in quadrant 1 or 4. What if I'm in quadrant 2? Hold on just one second. Sorry. It doesn't mean that we can't find it. What it does mean is that I would have to manually add on to it to get it into the right quadrant. So that's what this other piece over here is. If it's in quads 2 or 3, I need to add pi onto it, because that's half a rotation, right? What would I add on to if I was in degrees instead of radians? Yeah. Or plus 180 if we're in degrees. This is what I would do for quads 2 and 3. All right, so we're going to put it all together. For the next 4 examples, we're going to put it into component form first, and then we'll use that to find the distance, the magnitude, and then we're going to find our angle of rotation using tangent. So for number 1, if I want component form for vector AB, what am I going to do? Yep. x2 minus x1, so 7 minus 2, which would come out to be what? 5. And then what do I do for the y part? So tell me what numbers to subtract. 11 minus 6, which gives me 5. So there's my component form. Just out of curiosity, because we'll need this in a minute, what quadrant would 5, 5 be in? Quad 1. Let's find our magnitude next. Magnitude is just distance formula. So I'm going to take the two components and square them. And then I still have to square root it at the end. 5 squared plus 5 squared would be what? 50, because I'd have 25 plus 25. Is square root of 50 fully simplified? How would I write that in simplified radical form? 5 square root of 2. So that's how I would describe the magnitude. And on your homework for 8.3, I want the magnitude in reduced radical form or in simplified radical form. How would you type that into the computer? If it was 5 radical 2 is your final answer, how would you type that in? 5, and then SQRT, parentheses 2. That's how I would want you to put it into the computer. All right, so we have our component form, we have our magnitude. What do we still need? Yeah, we need our direction. And what do I use to find direction? Inverse tangent. So theta is equal to the inverse tangent of y over x. What's y over x here? 5 over 5. Well, 5 over 5, we got lucky on that one. That simplifies to what? So I want the inverse tangent of 1, 45 degrees. So theta is equal to 45 degrees. I will warn you, most of the time it's not coming out to be a unit circle angle. Most of the time you're going to have to use your calculator and use the inverse tangent button. We got really lucky on this first example though. Let's do number 2 together, and then I'm going to set you guys loose on the last 2. What would my component form look like here? Negative 5 minus 3, which is what? Negative 8. And then what? Negative 3. Not minus 1. Why plus 1? Yep. Because we're subtracting a negative there, so it's going to turn into plus 1. So negative 8, negative 2 would be my component form. Now I want the magnitude. What do I do to find the magnitude? Yep, square root of x squared plus y squared. Please be careful. I know y'all are very, very smart, but it is also getting late in the year. Please don't just do negative 8 squared on your calculator. Your calculator will lie to you. When you square any kind of number, you get what as a result? A positive. Make sure if you're popping this in your calculator that you're putting parentheses around things. Hopefully that's not an issue with negative 8 and negative 2. Hopefully you guys are squaring those in your head. But for bigger values that you might not know what it is squared, be careful. I just see silly things happen this time of year that people know better than, but they do it anyway because they're in a rush. What do I get when I do x squared plus y squared? 68. Yep, because it's 64 plus 4. Can I simplify radical 68 at all? 2 square root of 17. So there's my magnitude. Let's do our direction. For direction, I need to know what quadrant I'm in. What quadrant is this in? Q3. So do I need to worry about that adding 180 on the end part? Yes, I do. The only times I don't need to worry about it is when I'm in which quads? 1 and 4. Okay, so theta is equal to inverse tangent of what?
2.
Yep, -2 over -8. Have to do the plus 180. Please make sure your calculator's in degree mode for this one. I want your answer in degrees here. This one doesn't come out as pretty. What are we getting? $194.036. Is 194 degrees in the third quadrant? Yes. I want you guys to do 3 and 4 on your own. I'm going to give you about 5 minutes for that, and then we'll check yours against mine. So take about 5 minutes to do number 3 and number 4. Ma'am.
When you for this one, after that you add it together, you add 180.
Mm-hmm.
What happens if you add it like all together and the equation?
And then do plus 180 right there.
If you added the you guys can have the same answer, or they need to be changed?
So because you said you're in degrees here, it's going to take this answer in degrees, and then it's just going to add 3.14 to it.
Oh, okay.
So you want to add 180 if you have it in degree mode. If you have it in radian mode, what you wrote would be totally fine.
Oh, okay, that's why.
Yes, that's a great question. What is component form for number 3? 7-4. Because I'll need to know it for the direction, what quadrant is that in? That's quad 1. So do I have to worry about adding 180 or pi or anything? No. Okay, so then I do 7 squared plus 4 squared. So 49 plus 16, which gives me what? Radical 65. Can that simplify at all? No. Is 65 prime? Alex, you're shaking your head no. Tell me why. Yeah, we can divide it by 5. 65 is 5 times what?
13.
5 times 13. 5 and 13 are both prime. So their product can't be simplified as a radical because I don't have any perfect squares in there. So for my direction, I'm going to do inverse tangent of what? Inverse tangent of 4 over 7. And you guys found theta to be about how big? Yep, 29.745 degrees. All right, so number 4, what was component form? 13.2, which is in which quadrant? First quadrant again. So I'm going to do 13 squared plus 2 squared, which gives me what? Radical 173. Is that prime? Yes, it is, which means it cannot simplify any further than that. If you can simplify it, reduce that down, put it in simplified radical form, pull out any perfect squares. But if there are no perfect squares to pull out, leave it as a radical. And then inverse tangent of 2 over 13. Do I have to worry about adding anything? So what is our angle approximately? You said what? Yep. 8.746. Do you guys have any questions for me about this? Component form, wedge form, takes my vector and moves it into standard position. And then from standard position, I can determine the length of the line segment, that's its magnitude, and I can determine its direction as an angle. All right, flip over to the next page. We're going to talk about something called unit vectors. Do you guys remember the unit circle? How could you forget? What's the radius on a unit circle? 1. So what do you think the magnitude on a unit vector is? 1. So an example of something that is a unit vector. The vector 4/5, 3/5. That is a unit vector. It has a magnitude of 1. I'll prove it to you. How do you find the magnitude again? Yep, we would do the square root of x squared plus y squared. Well, x is 4/5. Y is 3/5. What is 4/5 squared? 16 over 25. What's 3/5 squared? 9 over 25. What do I get when I add those two fractions together? I get 25 over 25, which reduces down to 1. And the square root of 1 is 1. So that's how I know for certain that this is a unit vector. Unit vectors are any vectors that have a magnitude of 1. There are 2 very special unit vectors. Those two very special unit vectors are vectors called I and j. The vector I in component form is 1, 0. So if anybody wanted to be a guessing person, if I were to write j in component form, if I is 1, 0, and we know j is a unit vector, does anybody want to take a guess at what this looks like in component form? 0, 1. I can take any vector that is written in component form, in wedge notation, and I can write it as a linear combination of a scalar, that's magnitude only, multiplied by one of these unit vectors. And that's what we've got written down right over here. I can write something in wedge notation as 3, 5, or I can write that as 3i plus 5j. Because this one is getting multiplied to 1, 0. So that would preserve the 3, and it would ignore the 5. And over here, 0, 1. So that's going to ignore the 3 and preserve the 5. Does that make sense? We're going to practice that a little bit down below. We're going to find the component form for each of these, and then we're going to rewrite them as a linear combination of these unit vectors I and j. So what would my component form be for number 1? I'm sorry, what'd you say? 8, 5. So there's component form. How would I write this in ij form then? 8i plus 5j. Being able to write it as a linear combination of unit vectors means that I'll be able to do things with vectors that you know how to do with linear equations from Algebra 1. What about number 2? What would that component form be? I'm sorry, just a little louder. Negative 12. And negative 4, yes. So how would I write that, instead of in component form, how would I write that in ij form? Yes, negative 12i minus 4j. Beautiful. Last thing I want to touch on with you guys for today is where it says vector operations. We have 3 operations that we can perform with vectors. One of them is called scalar multiplication, and then we can do addition and subtraction. And I'm going to define what these look like. So let vector A in component form be A1, A2. And vector B, that's going to be B1, B2 in component form. For scalar multiplication, so for example, if I did 5a, so 5 times A1 A2. I multiply each of the components by the scalar. So it becomes 5A1, 5A2. So I multiply both the x part and the y part by that scalar. For addition or subtraction, so if I'm going to add or subtract vectors A and B together, I'm running out of room because I'm writing too big. You are going to perform the operations with the corresponding parts. So you're going to add or subtract your x's together. You'll add or subtract your y's together. So A1 plus or minus B1, A2 plus or minus B2. So let's practice that with these 3 examples and then we'll call it a day, okay? Let's start with number 2, because it's easier. What's going on in number 2? Just multiplication. So I'm taking -3 and I'm going to multiply that by the vector w. What is the vector w? -4 and 1. So I take this -3 and I just distribute it to both pieces. So what would my new vector be if I multiply each of these by -3? 12, -3. That is scalar multiplication. How would I write that one in IJ form? (12i minus 3j). Let's do number 1. Number 1, I have another scalar. It's being multiplied to which vector? W again. So -4, 1. And then I'm going to add that to the vector z. What's the vector z? -3, 0. So the first thing I'm going to do is distribute my scalar. So I would have -16, 4 plus -3, 0. And now I just want to line up my x's and my y's. And I'm going to combine them together. So what would my resultant vector look like? -19, 4. What would that be in IJ form? -19i plus 4j. I want you guys to do number 3.
when you're saying that it's A1 plus B1, are you referring like the 16? It's not gonna be like negative 16 plus B, like plus 0?
So if you do -8 plus 8, because it's a plus sign in between, what's going to happen there?
Don't use those two
Yep, those two are going to cancel.
and those two.
Those two are going to combine also.
All right, so help me out. We got just enough time to finish this up. When I distribute the scalar to W, what's my result? -8 and 2. I'm going to take that and add that to the resultant vector of 4y, which is going to be what? 8 and 20. And then I'm still going to subtract -3, 0. Oops. So when I combine all the x parts together, what do I get? -8 plus 8 minus -3. 3. And then I'm going to combine all the y parts together. 2 plus 20 minus 0. 22. What would that be in IJ form? 3i plus 22j. Beautiful. Guys, I have opened up the homework because now we've done enough problems that you can get started on it. We have not done any story problems yet, though. That's what we're going to focus on tomorrow. We will finish 8-3 tomorrow. So those of you, seniors, that know you won't be here on Monday, because I'm not dumb. I've been doing this for a minute. It is a college level class, so I'm not moving when the quiz is. But if you know you won't be here on Monday, like I said, we are finishing tomorrow. I'm going to start 8-4 on Friday. If you know you won't be here on Monday, make sure you take that quiz on Friday. Okay?